Hello, I'm Josh and this is Lexy and we are your STEM ambassadors for 2025. Joining us today is Dr Yazbek to talk about his scientific research. So Lexi, could you introduce the first question?
Okay, starting off with our first question is, could you tell us a little bit about the research that you do?
A little bit about the research I do. So I was running a research program at Flinders University. We were developing new breath test technologies in order to be able to detect things like cancer, gastrointestinal disease, infectious disease. We were looking at things like cystic fibrosis and other conditions. We were taking a few different approaches in that research program.
What would be the hardest part of working in a team?
Look, I think that's a challenging question. I think in science, working in a team is something that people strive to do, okay? Science isn't like it was 100 years ago even, where a lot of science was done independently. You know, you had a scientist working on their own in a lab making these big discoveries. Now science is team-based, team-oriented. Mm-hmm. You have scientists from all over the world working together on a single project, all unified to achieve a single outcome. From that perspective, that's probably one of the major challenges, is trying to get everybody who are so spread out working cohesively to achieve that goal, that outcome. But with travel and modern forms of communication, that's become a lot easier. When you say team challenges, it's probably not so different to working in a team like you get in high school, right? Someone doesn't pull their weight, someone doesn't do what you want them to do. So having those difficult conversations can be challenging as well, yeah.
Building on from that, out of all the famous scientists, living or dead, which one would you like to work with the most?
Yeah, this is an interesting question when I saw it. I was like, who would I like to work with the most? Because there's so many cool scientists throughout history, right? Growing up, you'd hear names like Galileo Galilei and the work that he did in exploring the stars and the solar system. You learn about Isaac Newton, you learn about Charles Darwin and the work they did. But I think for me, the person who I really admire and the work that they did, but also the barriers that they broke down, was Marie Curie. In terms of being such a renegade in a male-dominated industry, for her to make the discoveries that she did in the time that she did, and to win 2 Nobel Prizes in 2 distinct fields of science, I think she'd be pretty amazing to stand alongside, have conversations with and learn from. Yeah, definitely.
Well, we have a little game that we're going to do. It's called True or False. In this game, you'll be given 3 facts. They may all be real, they may all be false, or a combination. You have to guess which facts are true and or false. Okay. Fact number 1. The ocean absorbs sound waves better at night due to the cooling of the surface molecules, increasing hydrogen bonding.
That's a hard one.
Being a science teacher, I run the risk of Look, I'm going to say that sounds so obscure that it must be true.
Okay, next fact, we have water can boil and freeze at the same time.
Oh, I think I know this one is true.
I feel like it would be true, yes.
Yeah.
You can fit all the planets in our solar system between the Earth and the Moon.
Surely not. I feel like you wouldn't.
We just did this with the year 7s.
Oh.
Let me think. Mental calculation. I'm going to go with true.
So the first fact with the whole sound wave absorption, that's actually false. Sound absorption does depend on temperature, pressure, and salinity, but not the time of day or molecular bonding shifts. All right, the next fact is true. Yes, water can boil and freeze at the same time. This is a phenomenon known as the triple moment. Temperature and pressure conditions allow all 3 states, solid, liquid, and gas, to coexist. And as for the planets in our solar system, this is true. The distance between the Earth and the Moon is roughly 348,400 kilometers long. The diameter of the planets combined fit within that distance quite cosily.
There you go. I didn't know that. Learned something new.
Yes. All right, on to round 2. A day on Venus is longer than a year on Venus.
I feel like that was true. I feel like I've read that somewhere.
True.
Yeah.
True.
All right. If you drilled a hole through Earth and jumped through it, it would take approximately 42 minutes to get to the other side.
It's so random. I feel like that has to be true. Like, how do you make that up?
I'm going to go with false on that one. Yeah.
Okay.
Yeah.
Venus emits a unique type of radio wave due to its dense sulfuric acid clouds interacting with solar winds.
I'm going to go with false on that one.
Yeah,
Let's see what
false.
you
I
reckon.
reckon
You're going
false,
false
yeah.
too? Okay.
All right. Number 1. A day on Venus is longer than a year. True. Venus rotates very slowly, taking 243 Earth days to complete a single day, while its orbit around the Sun takes 225 Earth days. Very weird.
There you go.
My year 7s will be happy with that.
As for the second one, true. If you do drill a hole through the Earth and jump through it, it would take 42 minutes. This accounts for gravity changes, making it a theoretical time of 42, minus air resistance and molten cores, because it's quite hot down there. As for the third one, false. Venus does interact with solar winds, however, it does not emit a unique type of radio wave as a result. So there you go.
Okay.
Some fun
Right.
facts about our universe.
Okay, next question. What field of science did you initially want to study and work in, and how do science careers change or evolve?
All right. So the field of science I originally wanted to work in is an interesting question because I originally wanted to do medicine when I was at school. So I guess you don't refer to that as a field of science, but obviously science heavily influences medical practice. Obviously, I didn't pursue that pathway. I did my Bachelor of Science at the University of Adelaide, and as part of that degree, in the final year of my physiology course, we got placed in a laboratory. And in the course of undertaking that project at the lab at the Women's and Children's Hospital, I became really interested in research and became keen on pursuing a career in medical research specifically. I'd always had an interest in medicine and in the human body and health and all those areas, and this was an opportunity to pursue a career that linked in those areas, but also allowed me the autonomy to pursue my own research questions and to pursue my own sort of program. And so I did my honours degree and followed that up with my PhD, where we were looking at something called inflammatory bowel disease, and we were investigating a new class of drugs to try and treat inflammatory bowel disease, and we were using mouse models to do that. So became interested in investigating gut and gut health, and that kind of led me on to my career in breath analysis research. So I guess I've always been in the field that I've been interested in. It's always been something that I've been passionate about in terms of health and medical research. And pursuing that career opened up a whole range of different pathways. And so I guess that leads into the second part of the question, what type of career pathways can open to you through a science career? And there are multiple careers directly in the lab, so conducting experiments, gathering results, but you can go beyond that. I was involved in research advocacy, meeting with politicians, advocating for health and medical research funding. A lot of my colleagues have moved into areas like commercialisation and patent law. There's people who work in the commercial space with medical research institutes trying to commercialise research discovery, marketing, and sales with pharmaceutical companies. Science communication, so trying to advocate and communicate science to the public. So many diverse pathways, and I think that's what's really neat about science, that you can start general and then go really broad and do things that drive your passion. Yeah.
If you would have contributed to one previous scientific breakthrough, what would it be?
This was an interesting question too, because there's so many breakthroughs that would be really cool to be a part of, right? But I think when I thought about this question, one of the coolest stories I've heard in science was actually two Australian researchers. So you may have heard of Professor Barry Marshall and Professor Robin Warren. Both Australian researchers, Professor Barry Marshall from Western Australia, gastroenterologist, and Professor Robin Warren, originally from Adelaide, a microbiologist. And they were responsible for discovering the bacteria that causes stomach ulcers. Okay, so there's a bacteria that lives in people's stomachs. Approximately 50% of the population has this bacterial infection, and every now and then it flares up and it causes stomach ulcers. And the way that they discovered that this bacteria caused stomach ulcers was that Barry Marshall decided, because nobody believed their story, nobody believed that this bacteria was responsible for causing stomach ulcers. Everyone thought it was just stress, right? And so Barry Marshall, they grew this bacteria in the lab, and then he prepared a vial and he drank it, and he became infected with the bacterium and got all the symptoms, and then he took some antibiotics and was treated. And so that discovery led to them receiving the Nobel Prize in 2006. And it was a monumental discovery in human health. It has a really cool backstory, and I think being part of that just would have been really cool. Just to see him drinking that and seeing what happened, I think would have been interesting. Yeah.
All right, well, that brings us to the end of our interview. Remember to keep an eye on the STEM forums for the events we've got next year. We have a lot planned. Hope you learnt something. I know I did, especially in our game. See you next year.